Let's do this question today, Leetcode 62, unique paths. The question says, given a robot from index 0, 0, return the number of paths it can take to get to finish point. Now let's figure out the mindset behind this problem. To get to finish point, you can either go from left to right from this position, or from up to down from this position. And to get to here, you either travel from left or top. So this rule applies to every position in this grid. Every position's value depends on its left and top. So it's a very typical dynamic programming problem. Our strategy here is to have a 2x2 dynamic programming array where every I and j indicates the number of paths to get to ij in this input grid. And in this case, our answer is going to be dp26 here. So we're using bottom-up dynamic programming here. And for bottom-up, we have 6 steps to fill before we write code for it. Define dp I and j to be the number of paths from starting to ij. Our transition, as we said before, every dpij is going to depend on its previous left and top. So it's dp I minus 1 j plus dp I j minus 1. And our answer finally is going to be dp n minus 1 dp n minus 1. Here comes our base case, which is going to be our first row and first column. Because in these two lines, there is only one way to reach every position in these two lines. 1, 1, 1, 1, 1. So base case is going to be dp 0 j equal to 1 and dp I 0 equal to 1. Our filling order is going to be left to right and up to bottom. Optimization, maybe we can have it. I'm sure in this question we can do optimization for it. Let's save this topic to the end of this video. And final question before we write a code, do we need padding here? In this question, I don't think it's too complicated that we need to use padding, but we can do it, but it's not necessary. So I'm not going to do padding for this question. Okay, so first and foremost, we have dpij. Size is going to match mn, which is the input array. And in step 3, we said answer is going to be dp m minus 1 and n minus 1, so we return this here. And now we can fill our base case. Then we're going to have 2 nested for loops to iterate our grid. This iteration is going to start calculating from position 1, 1 to 2, 6 to the end of the grid, excluding the first column and first row. And then in the for loop here, we start from 1 instead of index 0 to exclude first row and first column for our base case. In line 17, we copy paste in our transition rule. Remember, we're starting from I equal to 1 and j equal to 1, so I minus 1 and j minus 1 will not be out of bound. And then I think that's it. Let's try it. Yep, okay, now we must do optimization for it. How do we optimize this O of n square space? Imagine we're at the last row here. Our dp array is going to be of size m by n, but every position in our last row only depends on its left and top. We're wasting the first row. If you still don't know how to do it, let's look at this example here. Let's say we're at position ij here, and our last row was 1, a, b, c, d, e, because our first column is always going to be 1, and these letters will represent number of ways to travel to those positions. So this position is going to be 1, this is going to be a plus 1, this is going to be a plus b plus 1. When you're at ij here, you notice what matters to you is your left and top, but not this value. So you can overwrite the last row, which means in every position, you calculate your own value using your left and the original value of this 1D array. And after you do it, overwrite this value. Okay, let's see how we do it. Now you can have a 1D array dp with length n, because that's your column number. You don't need this. But you're still going to fill your base case 1, because your DP array originally will represent the first row. So it's going to be DP1. In this nested for loop here, as we said, we're going to calculate current value and override it. So int value will become DP. Now in this case, it's J plus DP J minus 1, because J is the row index here. And we finally override it. DP J is going to be our value. We will save this value in J for the sake of next J plus 1. So our answer will be DP n here, n minus 1. Okay, so after this problem, I would recommend unique paths too, just to see if you get the whole idea of bottom-up dynamic programming. It's not too hard, it just adds some obstacle in the grid, and you're going to do some more if condition in this nested for loop. Okay, I'll see you there.